Hello folks, we are back with this part 3 video. This is part 3. Last we did the part 2 video. Now we will have this part 3 video. Just check what it is. So it is like we are taking the derivatives. They have given us y equal to cos inverse x by 2 by root of 2x plus 1. If we are not beginners, we can do it in lesser steps. But assuming that we are beginners, we may require more steps to do this problem. So since we have just begun the exercise, I would treat ourselves as beginners and we will do this problem, in many steps. Later on, as we get the speed, we can cut the steps and we can do it in much more simplified manner. Okay, that will be acceptable. So let's see now how to do this. We know clearly that this is of the type u by v, it's a quotient. So we have to find the derivative by applying quotient rule. So what we will do is we will assume the numerator to be u and we'll assume the denominator to be v. And we will find out the derivative of the numerator du by dx. We'll find the derivative of the denominator dv by dx. We'll do it separately. Then we will apply the quotient rule and overall we'll try to get the answer. This is going to be our approach. So let's start right away. Let's call the numerator as u first and get settled with that. Then we'll go to the denominator. And we see that the numerator, it is not directly cos inverse of an x variable. It's another x by 2 or some other multiple. So let's make one more substitution so that we don't go wrong with the values. Let u be cos inverse of x by 2 and w be x by 2. If w is x by 2, then u becomes cos inverse of w. So we are having these two substitutions. We are calling w as x by 2. So like that, our u has become a little more simpler. What is the advantage? Du, when you take the derivative with respect to w, it will, because it is cos inverse, we know that the derivative is 1 minus 1 root of 1 minus w squared. So you have got the du by dw. So also, because w is x by 2, which is half of x, we know that when the constant is there, the constant moves out and you are getting the derivative of x. Derivative of x is 1. So like that, derivative of w with respect to x is just that half. Why? Because the derivative of x is just the 1. So that way you're getting the derivative of w with respect to x is just that half. Now we club these two derivatives to give you du by dx. So du by dx by formula is du by dw into dw by dx. That way it will be 1 minus root of 1 minus w squared into half. We could simplify this. 1 minus w squared, w we know is x by 2. So it's going to be 1 minus x squared by 4x. So we could do this simplification, you could get this equated 4 by 4. And this 4 in the denominator we know always goes to the numerator. So like that, this becomes 2 by root of 2 is there, this 2 is there, 4 minus x squared, where this 2 and this 2 can cancel. As a result, you are left with 1 minus root of 4 minus x squared. Just simple algebraic simplification. So that gives us du by dx. That means the numerator is done for us. Now we will concentrate on the denominator. And denominator we are calling now, we are going to call the denominator as, and let the denominator we call it as v, which is root of 2x plus 7. Now the same story, because though with speed we can find the derivative directly, but as beginners we may require one more substitution. So let's call some r or t or something. Yeah, let r be 2x plus 7. So that makes v as r raised to half or root r. Let's see what's the derivative of r with respect to x. Derivative of 2x plus derivative of 7. 2x, 2 is a constant which moves out, and derivative of x is 1. So like that you get this derivative simply 2, and the derivative of 7 being a constant is 0. So as a result, this overall derivative works out as 2. Now we will work out for the derivative of v with respect to r. By exponent we know root x is 1 by 2 root x. So like that, this is going to work as 1 by 2 root r. So we are done with both the derivatives. Now we will get back to the derivative of v with respect to x is derivative of v with respect to r and derivative of r with respect to x. So let's get them together. This is 1 by 2 root of r. R, because we know right away we can get the substitution, and dr by dx is 2. So the 2 and this 2 can cancel each other. Your overall derivative is root of 1 by root of 2x plus 7. So now in this step you have got your du by dx and your dv by dx ready. So that allows us to get the derivative of y, which we have assumed it as u by v. So your dy by dx, by formula quotient rule, we have v into du by dx minus u into dv by dx by v squared. So let's put it across. V for us is r raised to half, which is root of 2x plus 7. And du by dx for us, it is 1 by root of 4 minus x squared. This is our first term. Our second term is u, which is cos inverse of x by 2 into dv by dx, which is 1 by root of 2x plus 7. Overall derivative of v squared, v for us is root of 2x plus 7 the whole square. Because the root and square is there, judiciously we can write this as 2x plus 7. So this is going to be your derivative. If you want, you could simplify it, but as beginners, there's no harm if we keep it like this, right? Whatever little simplification we want, we could, if we want to equalize or so, we could do that, or else we could keep this as the answer. So that's how it comes. Your answer could be simplified. As beginners, there's no harm if we keep it like this. So this is how the derivative works. As time comes, as we get more perfect with the derivatives, things are faster and you're able to do this much better. So that's all for this video. With more problems, we come in the next video. Thank you.